Good morning. Good morning. This is the video for 8D chemistry, and this is Mr. Weiss, and it's the 19th of May. So I'm going to get a spot ready for taking roll of who's here on the 19th of May. And I see somebody already, so good morning, and say hello, whoever you are, and I can know who I've got. And we'll write some folks down here, give you some participation points for showing up today and doing your job as a student. Today we're going to practice learning a little bit more about reduction oxidation. In fact, maybe I'll write that on the board as a goal. All right, Albert is here. Good morning, Albert. I got one so far. That's a good start. So I'll write here reduction oxidation redox very good. Okay, I'm gonna look at my little sheet and see what I've got for you next time, or this time as it were. Okay, so we haven't done the math relationship yet. Could do that. Let's get our periodic table up. Put that up here. So we have that up. And let's see who else joins us here this morning. Math relationship, yeah, we don't want to do that. Well, Albert, while we're waiting, we did that, which is good. I'm going to try and burn something, and let's just see if it works. We talked about that already, right? I think that's steel wool, and I'm going to just try and burn a little bit. I don't know if I can do it without a Bunsen burner, but we're going to try it. I just got some matches. Hopefully I don't burn the basement down. Yeah, it worked. We'll look at that together in a little bit once I get a couple more. But at least it worked. You can see it got darker there. And we're going to see what that darkness is where it was just burning. Good. All right. Well, more on that later. A little surprised it worked without whatever. Well, Albert, I'm hoping we get some more folks here. If you want to text some others and let them know we're online, that would be swell. I know it was sort of short notice yesterday, but usually this is a pretty good connected group. Yeah, Albert, I'll ask you to do that. If you want to text a friend or two, see if they're getting online, that would be swell. Normally, I got more on by now. And the time is right. I'm pretty sure this is our class time. Well, let's just review while we're waiting. So, Albert, go ahead and find your periodic table. I'm going to ask you a couple questions. Let's take this. RB and S. Make what ionic solid? Oh, there's some more. Well, hallelujah. Okay, good. So now I got 3 of you. I got Solomon is here, Albert and Shvitria is here as well. Very good. And others, if you're joining, please sign up. Or you can text your friends and let them know we're online, see if they can join us here in the class. Okay, supposedly I got one more. So I got a 4th person, so let me know who you are. And a 5th as well. So hello, good morning, report in so I can give you some participation points. Yes, Solomon, I got you. You are here. That is good. Okay, well, let's go ahead and do this as a warm-up, all right? So with your periodic tables, find out where RB is. It's number 37. And find out where S is, sulfur, which is number 16. And find the charge each one typically takes, being in those groups, okay, like we did the other day. Then we're going to try and see if we can figure out what formula the ionic solid would be. So first off, my question is, what's the typical charge for rubidium and the typical charge for sulfur? Can you guys look those up while we're waiting for others to join us? So the charge for either one based on what group that they're in. Cool. Good. All right. So I got a guess already that this is the family that's got a 1 plus, the rubidium, and from Solomon, this is the family that's got a 2 minus. You got it. Good. All right. Albert's got the same thing. That's cool. And I think that's right because this is in the alkali metals family and the other one's in the oxygen family. And that takes the 2 minus. Righto. So then the formula for the sucker when we put it together is I need, well, that's pretty negative, right? So I need 2 of those. And a couple of you have it already. So I need RB. And now we put a 2 after which one? Which one do we need 2 of? 2 RBs or 2 S's to balance it out to get 0 charge? How about Shvitri help me out here? Oh, she's way ahead of the game. And she's right. Thank you. RB2S is your formula for your ionic thing. And the others got that as well. Super. Thanks, everybody, for participating. That is exactly right. Consider yourself warmed up. Supposedly, I got 5 people, so if there's 2 more that have not said who they are, please say hello so I can put you down. And if not, we'll just continue on. Okay, we're going to do a little bit more here. I'm going to go ahead and start, and it has to do with reduction and oxidation. These are words we had the other day in class when I actually got to see you. And we're going to review them. And what I didn't tell you is if there's reduction, there's got to be oxidation also. The two together are often called redox for short. So let's do an example. And again, I'm going to do the thing I did with Albert right at the beginning of the hour. I might have had you guys try this at home. And it was to burn a little bit of, hey, Sophie's here. Good. Welcome, Sophie. You might have tried to do this at home as I kind of asked you to. We're going to try it again right now. You ready? Here we go. I'm hoping I don't burn the basement down. Here we go. Well, I'm not going to burn it with this match. Oh, there we go. Okay, so Steel wool, fire, burning it. Not much though. Let's try that again. Okay, so clearly, whoops, there it is. There, I got it burning a little bit. You might be able to see it's blackened a bit. And the blackened stuff is where I've had my reaction happen. So we're going to write that just again as a review. We had a little bit of this the other day together. But that's my steel wool. Again, you can try it at home too. Do it over the sink. Do it while somebody's watching you. You might want to have somebody help you. Okay, so what do we got? We got steel wool. Burning. And we're going to do it as a word equation first. And by the way, I got supposedly 2 more that are out there. So other than Sophie, Shvitria, Solomon, and Albert, if anybody else is there, say hello so I know who you are. Okay, steel wool burning. The steel wool was made out of steel, obviously, but that's got what element in it? What's the main stuff in steel? The main stuff in steel. See if you remember from the other day. Or you give me the chemical symbol if you want for the main stuff in steel. Shvitria has it. Indeed. Everybody's got it. Good. And the symbol's Fe. Well, let's just write the word first. We got iron plus, well, what's it reacting with out of the air, folks? It's the most reactive element that we're breathing in and out. So what's the reactive element from the air? Who remembers? It's about the only reactive element in air. And Sophie's got it, as do all the rest. It is oxygen. So now I could just put it together as a name and call it iron oxygen, but oxygen changes its name, okay? So it's called iron. And what does oxygen change its name to when it's in a compound? It's no longer oxygen, but what? See if you know. So I get iron ox. Solomon's got it. Oxide. It's 2 words in English. So let me write it as 2 words or 1 word in German. Right, in German, so Eisenoxid. Now, that's what's called a word equation, okay? And we're going to change it to a symbol equation. Here, you're going to need to know this, so I'll just write, all right, that's called a word equation or reaction. Moritz is here. Good. Thank you, Moritz. Good, good. Okay, so the symbol, I think Albert wrote that, is Fe, and it was a solid. The symbol for oxygen, as we're getting it from the air, is what? Oxygen is what chemical symbol for the element? So taking it from the air, what's the symbol that we write? Not just O. We don't have it as separate O's. It doesn't come that way in separate packages. It comes in little packages of what? When you're breathing it. You're not breathing O's. What are you breathing? Shvitri has it, you're breathing O2. So that was a word equation. This would be like a symbol, chemical symbols equation. Here, I'll just put some dashes. Good, so we got iron plus O2, and that's a gas. I'll put a G for gas. Oh, I haven't told you this, have I? Shame on me. When I use these little symbols, S, L, G, those are the main ones you'll need this year. S, L, and G are going to stand for what? What are those little symbols? Can you guess? So S is, L is, G is. We need them for writing chemical reactions like I just started here. Fe, O2, and you guys got it, including Sophie. Good. So I got S is solid. L is if the stuff is a liquid like water. And G is if it's a gas. Lots of you got that. The states of matter, exactly. And P for plasma. Nice. If you ever do a plasma reaction, let me know. They happen in like the middle of the sun. So we don't do a lot of them around here. Now, the other important one is aqueous, which is dissolved solutions, but we're not really ready for that. You get a lot more of that in ninth grade. Okay, so here we go. Iron oxide, it's FeO. So what you've got to know is that this is, oh man, well, let's back up. This is review, but yeah, states of matter, right? Yeah, I got you, Moritz. Thank you, Moritz. Thank you for checking in. Good. Right. Well, we did this before. Let's see if we can remember. So redox reaction. This is actually a redox reaction. So let's see what's going on. Okay, Fe is a metal, and it's becoming Fe2 plus. There's no way to know that because Fe is here, and I told you not to worry about those, right? So I'm just going to give you that. Can I tilt the whiteboard? No. Yes, I can tilt the whiteboard. There, I'll tilt it for a while, Sophie, so you guys can see. Then I got to tilt it back. So there's what might have been covered up by the blurb. Yeah, so maybe you can see the bottom part again. So the bottom part, I had word equation. Iron plus oxygen makes iron oxide. Symbol equation, Fe solid plus O2 gas makes FeO. Okay, and this part is not so covered up. So I got Fe goes to Fe2 plus it's given off to become 2 plus. It's got to give off 2 what? You're welcome. How's it given off? It's given off 2 what to become positively charged? What's the iron giving off? You got it. Exactly. So see if some others follow suit. Yeah, it's giving off 2. Anybody else got it? Just Sophie, 2 electrons. So that's how we write it. So if I've got this happening, then the other reaction is oxygen, O2. And we know what charge that makes. Okay, it's O2 minus. So for that to happen, I've got to, and I should have done it over here, I've got to add 2 electrons. So it kind of makes sense. While I was burning this steel wool, the steel was giving up some electrons and the oxygen was taking them in. So I got the steel giving up 2 electrons, the oxygen taking 2 electrons. Now, here's the problem with this. Oxygen comes in pairs, so I got to double some stuff. In other words, the oxygen, it comes in 2, so I got to say, oh, I really make 2 of these over here. 2 O2 2 minuses. But if that's the case, each one needs 2, so altogether I need, are you following? I need how many electrons then for the oxygen? Each one needs 2, so together they need, thank you very much, they need 4 electrons. This together is the redox reaction. So redox is short for reduction and oxidation. Good, everybody's got that. Thanks for participating. Oh, okay, good. Let's just remind ourselves. Okay, look at, here we go. I got iron going to 2 plus and oxygen going to 2 minus. Which one is reducing its charge? The iron or oxygen? Which one is reducing its charge as it goes from left to right? Which one's reducing its charge as we go from left to right? Where's the charge getting more negative? Now we got some solid answers. The oxygen. So the oxygen's going from 0 charge. O2 is an element. All elements are 0 charge. 0 to 2 minus. The other one's going from 0 to 2 plus. So this one is my reduction reaction. You still read that? Kind of. And this one is my oxidation reaction. It's an H, it's an N. Okay, so to kind of back up, we had this when I saw you live in person at the school, but it was kind of fast at the end of the hour. So we've got oxidation, we got the iron going to Fe2 plus and 2 electrons. And then we got the reduction, that's oxygen, it's reducing to O2 minus. So I've got O2 going to 2 O2 minus, 4 electrons having to be added because these come in pairs. And the big situation is the redox is I'm making FeO. FeO. And Tara's here. Hello, Tara. Welcome. All right, that is a little tricky. Do you have any questions? I'll tilt the board a bit so you can see. Do you have any questions about that so far? Okay, I'm going to change boards, but I'm not going to erase this right away in case you got something you want to ask about, okay? So this is a little tricky stuff, reduction, oxidation. I wish more of you were here, but at least I got 1, 2, 3, 4, 5, 6 of you. Okay, share this with your classmates. Okay, I want to get to some essentials. You ready? So here's some reaction essentials. And you might know some of this, all right? Okay, so I got and then arrow goes to All right, I don't want any chemicals, I want the general thing. Yes, exactly, Solomon. Okay, so the stuff on the left, you might have heard me say this year. The stuff on the left that we're beginning with, those are called the And the stuff you make on the right are called the hm-hms. So let's see if you know the name of the things you're beginning with in a chemical reaction or the things you end with. Either name would be swell. If you don't, I'll teach them to you. The stuff you make is called the products, and Solomon, you're right. So here we go. Whatever you make, that's a product. So I'm making one or more products. Compounds, a good guess, Sophie. This side, what you start out with, it starts with an R. And I don't know if you'd had it or not, so it's good that I asked. So they're called the reactants. Everybody say that, reactants. Yeah, I could hear you, that's good. Okay, so we got reactants going to products. Now, I want to tell you some things. This here arrow in the middle, we will need to talk about what it says in English and what it says in German. For starters, it's never put an equal sign. If you want to see Frau Althoff flip a gasket, really go mad, crazy, angry with you next year if you have her, put an equal sign, but don't, okay? So equal signs are what we use in math class. In chemistry, it's always an arrow because it turns out they're not equal. They're not the same anymore. Certain things are the same, but the chemicals have changed. So instead, what we say, forms, makes, yields. See, probably something else we could say as well. Okay, forms, makes, and yields. Those are the most common, okay? Or yields. In German, reagiert, probably it's reagiert, something like that, okay? I don't want to teach you bad German, but what I do want to tell you is I want you to never, ever, ever say, and this is a very bad Kennedy thing, we don't say reacts to form. That would be really bad Denglish, okay? Never reacts to form. The only people who say this are not thinking students from the Kennedy School. No one else in the world says this. So you just put like a red line through it, okay? All right, don't say that. But you can say para forms, para makes, para yields, and all those are just fine. And they're easier words to say. Why would you say reacts to form? Okay, it's just bad. Okay, so there you go. Those are some nuts and bolts of reactants and products, okay? All right. Now I'm going to pause here and erase my other board. See if you guys got a question. And we're going to do another reaction. And by the way, did you guys look at your schedules? I think I got you again, don't I? For 8th grade chemistry. Do I have you again in a couple weeks? Live, I mean, at the school? I think I got my 9th grade again. I want to say I think I got you guys again too. I hope so, because I got other stuff I want to show you, including some things we want to do and start now. Yeah, Tara thinks we do. Okay, I hope so, Tara, because I want to show you this as a reaction. We're going to do it right now on the whiteboard. And it's a reaction that has to do with, you ever hear this? This is called a hydrogen fuel cell. We hope it's a way to maybe power automobiles in the future, okay? And we're going to look at that reaction that's going to happen in hydrogen fuel cells. And I think it will be part of your lives, maybe not mine, but probably part of your lives as you go on, okay? So hydrogen fuel cell. So the title here is hydrogen fuel cell reactions, okay? And if I get to see you live again, I'm going to show you these reactions for art, right? I'm going to show them to you as a demo because it's cool and it's important. Two things from 8th grade, right? Cool and important. You'll like it. I hope I can show it to you. At any rate, here's what it is. A hydrogen fuel cell, a cell essentially combines chemicals to make electricity. Combines chemicals to make electricity. And I'll say here, like for a car. Or I'll say future car, question mark. Okay, so this involves, folks, hydrogen gas. Hydrogen gas. What's the formula for hydrogen gas? Elias is here. Good morning, Elias. So I need the formula for hydrogen gas. Anybody know? Thanks for the explanation, Elias. You can watch the rest of it on the live stream. Turns out hydrogen is a Brinkelhoff. You remember how those all are as a formula? A Brinkelhoff? Shvitri remembers. Shvitri has it. It's H2. So we got H2 gas. I'll put a little G for gas. And H2 gas, okay, it combines with something in the air that's pretty reactive. So what might it combine with in the air? Here, I'll tip that so you can see a little better. H2 gas. So you can just burn it with something in the air. What's in the air that's reactive? Hint, only one thing. We got it, good. So plus oxygen, so that would be O2 gas. And it forms, who knows? And I got somebody named Andrews in the wrong live stream. Okay, here we go. So H2 plus O2 gas forms what? Okay, let's find out. Okay, we're going to take these separately. We're going to do the redox reaction and find out what actually forms. Yeah, some of you figured it out already, which is cool. Let's take H2. So this is the redox. Let's do the other parts. So separately, the H2 and the, oh, well, let's just do H2. H2. What ion does hydrogen form? Look where it is on the periodic table, what group it's in. What's the typical charge when hydrogen forms an ion? What charge does hydrogen form? It's in the first family. What charge do those puppies form? You got it. Okay, so it's going to make H plus. But over here it's neutral. I don't usually put it, but I put a little zero. So it's going 0 to, so that means at the very same time, it's got to lose a what? What's got to come off? Here, let me tilt that so you can see it. What's got to come off to make it positive? What's it releasing? The hydrogen's got to release what? And Albert has it, an electron. So it's going to be like that, okay? However, I got two of them, so I got to double everything. Oh, man, so I got H2, so it makes two H pluses, and it gives off two electrons. Okay, good. Now let's try it with, good, everybody had that one. Thanks for participating. Let's do the other reaction, and that is O2. That also starts as a zero charge. Every element begins with a zero charge. I'm not making that up. It's just the way life is. Then O is over here, this family, that group. So what group does the oxygen group, what charge does the oxygen family take? So it's going to be O with what charge here? What charge will O take? Take a look at that oxygen family over there. When it becomes an ion, it becomes a charge. Shvitri and Tara and others got it. Well done. So it becomes a 2 minus charge. And that means to become 2 minus on the other side, the reactant side, new word, on the reactant side, that means I got to add 2. So on the reactant side, for this the guy to be 2 minus, I got to add 2 2 electrons. Thank you. But that's already not correct, because really, if it's O2, then I got to double this over here. Does this look familiar? Remember, we did this with iron. Okay, Elias wasn't here, but we just finished it with iron. So if I got two O2 minuses, I don't need 2 electrons. I need how many? Again, let me tilt that so you can see it. I don't need 2 electrons. I need how many electrons to make 2 O2 minuses from 2 things that are neutral? Shvitria, well done. So she says 4. She's right on her game today. Good. Okay, so here we go. I want to do something that we haven't done yet. Okay, check this out. See how we gain 4 and we lose 2? That's not so good. In the universe, if I gain 4 electrons, I better on the other side lose 4 electrons. You know what I mean? I can't have an unequal number. So what we're going to do is we're going to take this top reaction and multiply it by something. You might have done this in algebra class. I don't know. But we've got to have the number of electrons be the same. So I got 4 here. That's got to be 4. So I got to multiply the top reaction with hydrogen by what? Can you guess? That whole reaction multiplied by 2. You got it. So thank you. So we're going to do 2 of those suckers. Makes 4 of those and 4 electrons. Good. All right. Now we'll do something funny. We're going to add these together. You ready? When I add them together, the electrons, there's 4 here and 4 here. The electrons kind of cancel out. I don't know if you've had that in algebra class yet or not. If I have the same thing on opposite sides, I just put a line through them. Same thing in chemistry. So shaboom cancels with shaboom. But they only cancel if I got the same number. So 4 electrons on each side cancels out. So what I get, that doesn't fall over. what I get is what's left over. So I get 2H2 plus O2 makes 4 H pluses plus 2 O2 minus. I know this is looking complicated. It's going to get simpler real quick. So if you're not getting every single detail, kind of hang with me, okay? Just write her down and help me think about it. So look at what we've got going. We've got 2 H2s going with 1 O2. Well, that's what's going to happen up at top. So at the top of our redox, add a 2 here. Okay. Well, it turns out these H pluses and O2 minuses, some of you knew this earlier on, okay? What are these suckers going to make? If I had H pluses and O2 minuses, I'm going to get what compound will form? So what's going to form here? The H pluses and O2 minuses is going to make something we like, and we drink it and we shower with it and all that sort of stuff. I'm going to make things over H2O. So now H2O needs 2 H pluses and 1 O2 minus. Oh, but look at this. I got 4 H pluses and 2 O2 minuses. So I can make how many waters out of this? Try and tip that so you can see it. How many waters can I make out of 4 H pluses and 2 O2 minuses? Exactly, Sophie and Tara, 2. So, hey, there's our equation. Our redox is actually this. So when we form water, how boring is that? Or is it? I also get electricity. Or energy. So if I do it with what's called a hydrogen fuel cell in a potential future car, I can get electricity. If I just combine oxygen and hydrogen gas, then I can make them explode. And that's not so helpful. Long ago, there was a Zeppelin, right? A big, huge airship, air balloon, and they had it filled with hydrogen gas. And the thing went from Germany to the US, and as you might have seen the video of this, as it okay, I don't know who you are, but you're going to get removed by. Okay, I don't know if you saw this video, but when you have hydrogen gas and you burn it, it's really bad and it's very explosive. And the Hindenburg was an airship and it blew up. It was filled with hydrogen gas and it blew up very quickly. And that's uncontrolled hydrogen gas burning with oxygen in the air. But if you control it very carefully, you can make electricity out of it for a future car. So that's the idea with the redox reaction. Okay, before we leave this, let's review the words we had, okay? The first reaction here. So we kind of broke this into 2 parts, okay? And then we put it back together again. Check out this. This guy, we're going from 0 to 2 minus. So that's a reduction or oxidation. Which one is oxygen doing? Reduction or oxidation? What's happening to its charge? Remember I told you to remember it? 0, 2 minus. It's undergoing which thing? You know, some days it is not easy. Oh, I hope you're laughing. Someone might as well get some good out of it. Okay, anybody answer? We did, Albert did, thank you. It's reduction. So that's reduction. And the other one is therefore, I'm going to a higher charge. Hydrogen goes to a higher charge, right, from 0 to plus. So that's oxidation. And again, oxygen, I hate the name because it doesn't always have to do with oxygen. Here it's hydrogen that's undergoing oxidation. So it doesn't have anything to do with oxygen, okay? Sorry. But reduction's easier. The charge is reducing, so hence that. Okay, so this is sort of an intermediate step. And again, we can just sort of write another arrow. I don't usually do that, but it makes then two waters. I know I've run over a minute. Oxygen never gets oxidized. Never is a big word, Sophie, but I'll say 99.99% of the time, oxygen always gets reduced because Sophie, it likes to gain 2 electrons. So therefore, its charge goes down almost all the time. Good question, though. So look at this. Not only is this a nice thing to get electricity, the only thing I make is water. How cool is that? That's not a pollutant at all. It's a nice product. So I hope the hydrogen fuel cell is something you use someday. Good. Thanks for staying a minute over. Thanks everybody for participating. And unless anybody else is there who's not some weird person, I'll say see you whenever we can see you, and have a good rest of your day. Bye-bye.